And good afternoon, everyone. My name is Sam Nasser, and this is the Cleveland C# VB.NET user group. Our meetings are free of charge and open to the public. We meet every month, typically every fourth Thursday, and it's been online since COVID began, and we continue to do it online, so nothing is stopping us. We cover any and all topics related to .NET, and you can find meeting information for both past and present meetings over on meetup.com with the link listed there. Big thank you to our sponsors, Tech Systems, Inedo, makers of Buildmaster, PostSharp for sponsoring some of the prizes, and NIS Technologies for sponsoring the web hosting. Some general information, although it is an online meeting, we do encourage participation. Keep in mind that the only stupid question is the one not asked. So always feel free to jump in either verbally or through the chat window. However, kindly ask that if you're not chatting verbally, to kindly mute your microphones to avoid any background noise. And although the meeting is somewhat structured, we want to keep it casual. So again, jump in with any questions or comments when needed. The presentation is being recorded and it will be posted on YouTube, and the link will be provided in chat towards the end of the meeting. For tonight's presentation, it's Stacy Cashmore coming to us from the Netherlands, and it is currently a little bit past midnight over at her time. So not only do we appreciate her time to step forward and volunteer her time to give a presentation, but also the effort it takes to stay up past midnight and deliver an effective presentation. So thank you in advance for that, Stacy. A little bit about Stacy. She is a Tech Explorer for DevOps at Omniplan. She's been developing software since the mid-1990s, and she's been a Microsoft MVP in developer technologies. She's also active on the conference circuit, and when not programming, she loves spending time with her family and her classic car, which I would love to learn more about, by the way, and also playing the piano. So Stacy's going to be talking to us about getting started with Azure Command and Query. And so with that, I will turn it over to Stacy.
I want to say good evening to everybody. It's I guess it is good evening for you. As Sam said, it's a little gone 12:30 for me here, so keep your fingers crossed for me. It's if I can code at this time of night, I am going to be extremely happy with myself. So Azure Functions and Storage, how to get started with Command and Query using Azure in a simple way. So as developers, we want to work on the latest things. It's what we enjoy doing, to be able to keep our skills up to date, to be able to use the best fitting technologies, and to solve problems in the best possible way. And cloud solutions have come to fit this description more and more. And yet, sometimes being able to use these technologies, it takes far more time than we'd really like it to. Some larger, some older companies, they can still be really hesitant about making that move to the cloud. And whether that's through fear of the cloud, lack of knowledge of the cloud, or other internal reasons, many developers still find themselves working on legacy in-house systems. Your code gets deployed, hopefully, far too occasionally, with a lot more effort than you'd like. And you've not really got that much control over how it gets deployed. And should you ever need new hardware, it might be months before it's made available to you. And at a previous employer, this is exactly the position that we were in. As a development team, we really wanted to make that move to Azure. We had a project that was screaming for it. But our ops team and our budgeting team, absolutely not. Not until you can give us some answers. Not totally unfair, of course, but then what answers are acceptable in this situation? Because there are reams of research about the move to the cloud, not least of which the state of DevOps reports. They continually support the move to the cloud. But we're dealing with people. And people aren't so easy to change. It doesn't matter what research you put in front of them. For them, it's still the unknown. They have this need to feel what they're doing and see the results with their own eyes. And so, to get that data that we didn't have, to allow them to feel and to see these results, and to prove what we could do, we had a hack week, a chance to show what we could build in a short time frame with the whole team working together. And for our budgeting team, let's have a look at the costs at the end of the week. And when I say the whole team, I really mean the whole team. All of our development teams got involved. Our ops team got involved. And to make sure that we weren't building some kind of simple tutorial that had no value in the real world, we got our product owners involved as well. Hi, as Sam said, I'm Stacy Cashmore. I'm Tech Explorer DevOps at Omniplan in the Netherlands, and I'm a Microsoft MVP in developer technologies. Been coding since the mid-90s, and for the last 2-3 years, I've been more and more focused on making that move to the cloud and getting into Azure. Now, the app that I'm going to show you today, it is based on a simplified version of one of our experiments. And basically what we're going to do is have a look at a simple way to get data in a disconnected fashion from a static Angular site and into Azure storage so that it's ready to be queried in whatever manner best suits the data at that time. Now, I've got a few provisos before I start. First one is I am using Azure DevOps to do the deployments for this demo, but I'm not going to be covering that in this talk. Also, because of time considerations, I am using a pre-made Azure environment because when you want to provision resources in Azure, it takes time. And I'm going to be honest, I would rather spend that time showing you things than just watching Azure say, hey, I'm doing something. But I am going to make sure that I show you how to provision each resource in the portal for whatever I use in my demo. Finally, before we start, I'm going to be going through this at a little bit of a pace, I'm afraid. But don't worry, I'm going to be sharing a blog post at the end that's going to explain things in more depth. It's going to go through each of the steps I use to build the application and to deploy the application, and with lots of links to the appropriate documentation on MS Learn and MS Docs. Now, enough of me just talking about stuff. Let's actually have a look at what we're going to be building. Now, the first thing I want to show you here is the application that I'm going to be using as my interface for my demo. It's a simple single-page Angular application to allow people to sign up to a book club. We're just going to be asking for somebody's name, their email address, and the genre that they're interested in. Now, this app doesn't change at all throughout any of this demonstration. All of the magic happens on the back end inside of our API. So let's take a look at that next. What I have here is an almost out-of-the-box scaffolded web API project. I have made a few changes to make this demo work, and I just want to walk through those with you before we start actually coding. First up, in our startup project, I said that my interface is a static Angular app. That means it's running on a different URL to my API. That means I've got to get course set up. So I just have this in my startup CS. It's not really important for the demo that I'm showing you, but I just want to make sure you see all of the changes that I've made. I've also included my local host because that just means that I can debug locally if I ever need to. Next up, when you scaffold a web API application, out of the box, you get a weather forecast controller and you get a weather forecast model so that you can just spin it up. You can go to the API, see what it's doing, and get data returned to you. I don't need those, so they're gone. And in their place, we have a book club sign-up request, getting their email, the name, the genre that we're interested from our users, and also a controller here, book club sign-up controller. It has one function, a HTTP post, where we get that book club sign-up request from the body of the request. Looking a little bit empty right now. So let's start to put something in here. Now, the first thing I want to show you today is really the simplest possible way to get data just into that storage table. We're using Azure storage accounts here to store our data. And I want to take the shortcut and just show you to get data from the front end and directly into the table. For that, we need to create a class in order to handle our Azure table. Now, I like to keep my code just a little bit organized. So I'm just going to create a new folder here. And we're going to call that table access. Inside of there, we're going to create our first class. And we're going to call that, if my computer works, wow, that was actually reasonably quick. Storage table access. This is where we're going to put our first bit of code. Now, you really don't want to watch me doing typos for the next 30, 40 minutes. And at this time of night, you really don't want to be watching me do typos for the next 30, 40 minutes. So I have an amount of code snippets that I'm going to bring across and walk through with you as we build up this application. So the first thing that we have is a using statement for Microsoft Azure Cosmos table. And we see a little red squiggle there, and that's because we need to bring in a NuGet package to make this work. So let's add the NuGet package now. And for the eagle-eyed out there, you may notice I'm bringing in a Cosmos namespace here. Even though I'm not using a Cosmos DB, I'm bringing in the Cosmos namespace because the API to access table storage is the same for both. It also means that we actually have an easy upgrade path if we ever outgrow our table storage account. So let's install that, and every pop-up we're just going to click OK, because does anybody ever really read these? And while that's installing, we can go back to our application. Now, the base of this class is quite simple. We have two private properties. One is a connection string, and please don't ever hard code a connection string in production. Make sure that you get that from some kind of Azure configuration service. And we have a table name, and the table name we're passing in to our constructor. We're doing that because we want to reuse this class for all of the tables we want to access. We don't want to have a different class for each table. Now, today we're only concerned with putting data into this table. We're not going to get to the querying part of the command and query. So we're just going to add one function for inserting data. And this function takes a table entity, which comes from that Azure Cosmos table namespace. And this is a special type of object which allows us to interact with table storage. Inside here, we have three commands. We're going to get our table. We are going to make an insert operation based on the data we've passed in, and then we're going to execute that against the table we get back. We still have red squiggles here. So let's bring across another function. And this function is actually going to give us access to that table. So in here, we'd have 4 steps. First of all, we're going to use that connection string we've made above, and we're going to get access to our cloud storage account. Using that cloud storage account, we're then going to create a cloud table client so that we can talk to our different tables. And then we're going to get a reference to the table name that we passed into the constructor. Now, the really fun thing here is this table doesn't actually have to exist. You can do code first and just reference non-existing tables. Unfortunately, what you can't do is access non-existing tables. That will throw an error at you. So we need this last step, table.create if not exist. And this does exactly what it says on the tin. The SDK will check to see whether or not the table exists. And if it doesn't, it creates it for you so that you can then use it in your code. We then return that table, and we can carry on with the rest of the insert operation. And for purely throwing data into a table, this is all we need to worry about. It's not all we need to do in order to get our demo working, though, because right now we don't know what data we're storing. So we just need another class in here, and we're going to call that sign up entity. And this sign up entity is going to be based on that table entity. So we're still importing that Azure Cosmos table namespace. We're inheriting from table entity. And when you do this, there's two properties which we must fill. One of them is a partition key, how we're going to partition our data within our table storage. And the other one is a row key. Now, a row key has to be unique within a partition key. And between the two of them, you get a unique identifier for your record. Now, you may notice that I have wrapped these in a property with an ignore property attribute attached to it. You do not need to do this, but I kind of like to because I prefer not to have partition key and row key spread throughout my code. I like to kind of wrap these in something that makes a little bit more sense for the domain that I'm working in. Of course, with the code that you see here, we're still not storing any data. We still only have the partition key and the row key. So let's actually bring across the data that we want to store. And for that, we're going to bring across our name, our email, and our genre again. So this now should work. This should create a table. It will insert the data for us based on this particular model. We just need to use it inside of our book club controller. So for that, I've just got a little bit more code to bring across. Inside of our controller function, we have two lines of code. Let's just do a control dot here to bring in the using namespace for the storage table. We are getting access to the book club signups table from our storage account. And then we're going to insert the request that we get from our Angular application into the storage account. Of course, this object here isn't a table entity, so we need to adapt it. Again, kind of the same as with the connection string. If you're going to do adaption, you're probably going to put it in its own class and keep it all single responsibility. For this demo, I'm just going to cheat and stick it right in the controller. And here we have a simple method. It takes in that book club signup request and just turns it into a signup entity. Most of it's relatively easy. You could do this with an auto mapper, taking the name, email, and genre and passing it over. And then we just have these two extra lines to set that genre subscription, my partition key, and my unique name, fantastic naming there, which is my row key. Now, when you design your data and you figure out how you're going to store it, you are going to come up with a really awesome mechanism to make sure that you don't get data clashes. I'm just going to take the ticks from datetime now. I'm going to put it onto the end of the name that comes in with my request. And I'm pretty much guaranteed not to get any data clashes and everything should just store. Let's give that a quick build and make sure I've not done something wrong. Yep, that succeeded. I'm now going to push this up to my pipeline and start to build it. And I'm going to show you the Azure resources that we need in order to run this. Now, I'm just going to come across to my command line, not because I want to show you how much of a command line wizard that I am, but just because I have an issue in Visual Studio at the moment. If I try and use a Git integration, it takes an age to do a push. So I just need to do that from here. So I just want to add all of my changes. I want to commit it with add table, and then we can push that up. There we go, that's done. That literally takes about 5 minutes from within Visual Studio right now. So if I switch to my browser, I just want to check that my pipeline's been kicked off. Otherwise, it's going to get really embarrassing in a couple of minutes. There we go, that's going. Now we can create our resources. Now, the first thing that I want to do for my resources is I want to create a resource group in order to group my resources. We're going to give that a name, live demo RG sounds good. And then we need to set the region. I'm in the Netherlands, so I'm going to be running inside of West Europe. This region can be a little bit confusing the first time that you create a resource group. It certainly confused me. I know a few other people who did as well. I assume that if I'm setting the region on a resource group, then that's going to default the resources within that resource group. It doesn't do anything of the kind. It does have an amount of metadata that it stores about your resources, and that's important. because that can have compliancy implications. So when you make your resource group, make sure that the region is suitable for where your metadata needs to live. Let's just create this one. And there we go, that's all done. Now, in my intro, I said I'm using a pre-made environment because provisioning resources in Azure takes time, and this was instant. Honestly, I wasn't lying to you. This is the exception that proves the rule. I've never had this take longer than a second or two. The rest, unfortunately, can take a bit longer. Inside of our resource group, in order to run the code that I've just showed you, we need 3 resources. We need an app service plan, which is kind of the metal that we need to run our application on. Then we have a web app that we need to create. Think of that as the IaaS application that we're going to be running inside of. And of course, we actually need that storage account where we're going to be storing our users' data. Let's start with the web app, that IaaS application. We can come into the create resource and we can click on web app here. Then we get this nice panel. We can check the subscription and the resource group is correct. It should be, because we created it from inside of a resource group, so it should be pre-filled for us. And then we need to give our web app a nice name. So let's just call that demo. And we can't. And we can't because underneath that box, you can see it says azurewebsites.net. That is, this is how our web app is available to the outside world. This has an implication of it has to be unique inside of the entire Azure system, not just your own resource group, your own subscription, in all of Azure. So you have to think of a nice naming convention to make sure you have something which is easy for you to recognize, but it's also going to be unique when you come to use it. So for now, we're just going to do live demo web app, and that's available for us to use. That's good. I'm deploying to .NET 5. I'm going to be running on Windows. There's a reason I'm not running on Linux. I'll come to that later on in the demo. And again, there we go. The region is still set to Central US and not to West Europe, where I'm located. Now, I said as well as the web app, the IaaS, we also need the metal that we're going to be running on, that app service plan. And thankfully, in this screen, you can actually create both at the same time. Slightly less clicks that you need. So we're going to create a new one here. And this doesn't have to be unique inside of Azure. So this one, you've got a lot more free reign in naming it, if I can speak English. And this is going to be an app service plan. After we've named our app service plan, we need to pick the size of the app service plan. How much money do we want to spend to run this application? And if Azure is nice and quick for me, I can actually show you some of the prices here in a second. There we go. For a production workload, we can go from 62 euros a month up to a whopping 832 euros a month for our standard production workloads. There's 2 important things here. One is you can pick an app service plan which is specific for your needs. So if you need lots of processing power, you can pick that and pay for it. The other one is people think that if you're working in the cloud and it's easy to provision stuff and it's easy to scale stuff, that it's much easier to throw metal at your problems to solve issues that you have. It is easy. It's also hideously expensive to solve problems that way. So do make sure that you figure out what kind of workload you need and make sure that your app's written in a way that can support that. Now for development and for giving demos like this, I really don't want to be spending that money. So we have this dev test workload. And here we have 3 options. We have a free option. I like free stuff. There we have 1 gig of memory, 60 minutes of compute time a day, and very little included options. Now, when it says compute time a day, that isn't how long your web app is available for per day. It is literally the compute time for your web app. So if you are sending in requests and causing 2 minutes of CPU time an hour, you can use that 60 minutes and not run out of compute time in a day. If you need more than that, obviously you can up it to 4 hours per day for 8 euros a month. And you also get custom domains if you move up to this level. So you can actually make your development site with a proper URL. And if you move up to the next level, then you can even do manual scale out on your development workflow and make sure that that's going to work for you. Like I say, I like free stuff. For this demo, it's perfect. So this is the one we're going to pick. So let's review and create that. Make sure I've not done anything wrong and click the create button. So Azure's going to go away and provision this. It'll take a couple of minutes for that to happen. In the meantime, let's go back to our resource group, which, as you can see, is still empty because it's not provisioned yet, and create our storage account. So we'll go back to this add. We'll create a storage account. And then we've got a few things that we need to fill in here. Again, subscription resource group are pre-filled because I did that from. Now that's very interesting. Azure has never done this to me before. I created this from inside of the live demo resource group, and the resource group has been defaulted to a different one. Let's fix that. See, this is why it's always good to check it. Then we need to give our storage account a name. So if we call that demo, you can probably expect, yep, this also has to be unique inside of Azure. So let's call this live demo. And I can't do this either. For some reason, I honestly don't know why. Storage accounts names can only be lowercase letters and numbers. No Pascal case, no camel case, no kebab case. Just big, long, massive strings that are unfortunately a little bit difficult to read. So we want live demo storage ACC. Is that one available? Come on, Azure, talk to me. It's always fun when the Azure portal gives you issues. Yeah, let's see if that works. Then we need to say the region that we want to go into. And again, I'm in the Netherlands, so I want West Europe. And the region that you create your storage account, it's important for two different reasons. One of them is latency. When we read data out, it takes an amount of time. When we move that data to our application, it also takes an amount of time. If your storage account and your metal are in the same region, it's going to be in the millisecond range. It's going to be perfectly doable for most applications in the world. If you host your data somewhere else on the other side of the world, that latency can really build up. And if you're getting lots of data, it can really degrade your user's experience. So try and keep your data as close to the metal as possible. Second issue, same as for the metadata for the resource group, is compliancy. I'm in the EU. If I am asking personal data of my users and they're in the EU, my data also has to live within the EU. So it's really important, again, when you're creating something, keep it close to the metal and make sure you know where you need to keep your data in order to comply with your local regulations. Next, we need to pick the performance tier that we want. And for that, we have two options. And as I does say, kort door de bocht, to take a shortcut. Premium is more expensive. It's faster. Standard is cheaper. It's slower. Data throughput and all sorts of other things also have an impact here, but that's pretty much enough to know. And I'm looking at this right now, and the portal has changed since this afternoon. That's quite interesting. There's a couple of different options here that weren't here earlier. So now we move on to our redundancy. And I thought this was going to be different. This is cool. This is the first time I've given a talk and seen this screen. It used to be that we had 6 options available here. Now it's gone down to 4, but we have an extra checkbox underneath. So let's have a look at the options that we have available to us. The cheapest option, locally redundant storage. And I really love this. The cheapest option that we have, our data is still protected against equipment failures. It's copied several times within a data center. The next level up, which I don't know why it's not the next one down in this list, it used to be in the big list of 6 options, is zone redundant storage. This is where you're protected not only against that equipment failure, but if a whole data center falls out of the air, then we have the ability to access our data still. Sorry, my brain's just registered the time of the night that it is. Apologies. Next up, we have Geo-Redundant Storage. And this is where we don't copy our data within the region, we copy it across different regions. And that means that in the event that an entire Azure region suddenly becomes unavailable, doesn't happen often, but I have experienced it twice, your data is still available in that secondary region. And there's two different options that you can do here. One is that you can have read access in the event, or just always. And the other option is that you have read access in the event of your primary region not being available. Why would you want to do those two different things? Well, if you have read access in the second region, it's more expensive. If you don't need it, it's cheaper not to use it. However, the failover for regional unavailability can take time. If that time is longer than you are permitted within your SLAs, then you can make your data readable in the second region, and you can have a heartbeat and you can perform your own failovers. The other option, which is probably more useful day to day, is we have our users spread around the globe. Say I have an application and it's running in the Netherlands, where I'm located, and France and Belgium. So I'm probably going to host it in West Europe. But I've also got users in Norway and Denmark and Sweden. So I'm going to have users that are probably going to be closer to North Europe. I can duplicate my data from West Europe to North Europe, and I can have read access for all of my users in that North Europe region. I can duplicate my metal, I can make sure they can read from it locally, and I can give them a better experience than making them come all the way to West Europe in order to get the data. Now, in that type of distance, it's probably not going to make the world of difference, but you get the idea. You still have to write to your primary region, so all the writes would still come to West Europe, but at least for the reads, you've got that performance boost. And then we have an option which came in last year, and that is Geo-Zone Redundant Storage. Pretty much the same as Geo-Redundant, only now it's copied not only across regions, but also across zones. They've just got that extra layer of resiliency built in here. And again, there you can have read access, and you can have read access only in the available of regional unavailability. Now, for me, again, for the demo, this is non-critical. I'm going to go for the cheapest possible option. So let's review and create this one. And that's it. Azure will now provision everything we need for the code as it's written right now. Now, there's one more thing that I want to show you before we proceed, and that is my pre-made environment. So if I come into my running demo, in here, I have this storage account set up, Azure running demo. And if you open this, you have this Storage Explorer preview. Now, it used to be that if you needed to non-programmatically see the data in a storage account, you had to run this Storage Explorer locally. If you're doing something complex with your data, that's still a better idea than using this in the browser. It's still in preview. It's a little bit simple and it has some foibles, but for just quickly checking your data, it's awesome. The data that I want to show you right now is there is nothing in the hat. Tables is empty, queues is empty. I told you that we could create these on the fly. We didn't need to have them set up before we run our code. And hopefully I'm about to prove that to you. So my pipelines ran. So let's get some data in our database. So we have, if I can type, Amy Pond. And Amy Pond, and Pond is with a capital P. And Amy has an email address at the TARDIS. And anybody who knows Amy, they know that she is interested in 40s crime noir. So let's submit that. That will now go to the API that we've just deployed. It will get access to that storage account. It will see that we don't have a book club sign-up table. It will make it, and then it's going to insert the data in there. Yeah, I was stalling for time to make sure that the API was actually up and running. Now, if we refresh our Storage Explorer and we go to tables, we now see that we have this book club signups. We have Amy Pond in there, processed, ready to be read out in whatever way we need to. It's a really simple way of doing this, and it has issues. The first issue is this is written synchronously. It all happens inside of our web API. Now, right now, that's fine. It's super simple. But in real life, we wouldn't just be doing this. We would be checking the email address. We would be maybe doing a double opt-in, making sure that the user really wants to sign up. We're going to be creating an account for Amy and any other thing that we want to do when somebody signs up to our book club. All of these things take time. All of these things take processing power. And if we have a sudden rush of people joining our book club, and why wouldn't they? Amy is a member. Then our API can get flooded. It means we have to scale out an entire app service. It's quite a big thing to do. And you might not need it for the entire time. These things might come in waves of people trying to do stuff. There's better ways of doing this. The other problem is all of those things I mentioned, the sending the emails, the double opt-in, the making the account for Amy, they can go wrong. They can cause errors. And if you put that in your API, then you're going to be returning a 500 error to your user. They're going to be swearing at you because your website doesn't work, and you're going to lose them. I'd rather make those failures my problem and not Amy's problem. So what we're going to do is take Amy's data and we're going to put that in a queue. Amy gets a reply back straight away. This is something that doesn't have to happen instantaneously. She can go away happy. We're going to tell her that we'll create your account somewhere in the next 15 minutes. And then we're going to read that using an Azure function. And this is where we're going to handle all of the data. This gives us those two advantages. It means that the API stays really thin and really snappy, and it works. And our function, we can control the scale out so that we don't just go over the top with scaling if we get a sudden rush. We can limit it because this is something that can batch process in the background, as long as we're not going over that 15-minute mark that we've told our users. The other thing we have here, if it goes wrong, we can catch that error, we can store that somewhere else, and then we can look at that error, we can fix the problem, and we're going to be outside of our 15-minute window, but we can still solve the problem without unduly causing problems for our users. So that's going to be the next stage of what we do. So we're going to go back into our API, and we're going to do a little bit of cleanup because we no longer want all of this complex code. So we'll get rid of those two lines. We're going to get rid of this adapt and keep in the table access because I'm going to cheat in about 5 minutes. But we're not going to be using inside of the API anymore. Rather, we're going to be using a queue. So for that, I'm going to create another folder because, again, I like to keep things just a little bit organized. And I'm going to try and not, misclick. Coding at 1 o'clock in the morning. Awesome. So there's our queue helper folder. And in there, we're going to put a class and we're going to call that queue access. So we're going to add a class, call that queue access, and there we go. And I've got more snippets to bring across and build this up with you. So first of all, we have our Azure Storage Queues using statement. This is a namespace we're going to be using for accessing the queue. And again, we have a red squiggle. We have a red squiggle because we need another NuGet package to make this work. So let's add that one in here. We're just going to pick the latest version of this. We're going to accept everything and then come back to our class. Now, at first glance, this looks reasonably similar to our table access class. We have a connection string. Don't put this in hard-coded in production. And then we have a queue name instead of a table name. And we're passing that through the constructor again. Same reason as before, we want to be able to reuse this class for all of our queues. And the same as with the table access class, we're only going to be dealing with adding things to our queue today, I'm afraid. So we have this add task here. It takes an object, just a plain old object. We don't need any special entities for talking to a queue. We are going to get a queue client. We're then going to convert our message to JSON and encode it in base64. I'll come to why in a minute. And then we're going to send this base64 encoded JSON string to our queue. Let's get rid of that first squiggle. Let's see how we get our queue client back. And this is one step less in creating a table, but you can kind of see the same flow here. We get access to a queue service client using our connection string. From that queue service client, we get a queue client using the name that we passed into the constructor. And then again, a queue doesn't have to exist. So we call this create if not exists async. Does exactly the same as for the table. Checks to see if it exists, creates it if not. Interesting one here, when I first started doing this talk about 12 months ago, this didn't exist. It wasn't yet on the SDK, and that meant you had to write this by hand. I was so pleased when this became available because any code I don't have to write is not going to have the bugs in that I can put in there. Anything that I can put onto somebody else, all the better. Now, the last thing that we need to do is add this to base64. And we don't need that inherently for a queue. A queue can take a standard string and you can read a standard string back. You will see it in the Storage Explorer. But if you use a queue trigger on an Azure function, as we're going to be doing in a minute, then it has to be a base64 encoded string. In a previous SDK, this was all taken care of for us. It's not anymore, unfortunately. So I know lots of people, when they moved to the new SDK, they suddenly had lots of errors. It's like, what? The old one was base64 encoded. It was taken care of so nicely and so quietly behind the scenes, nobody even thought about it. Nowadays, unfortunately, we do. I hope this disappears at some point. Again, I don't want to write this code. I'd rather that this is just taken care of for me. Now that we have this class, this does everything that we need it to do. The only thing that we need to do now is add one extra line of code into our controller in order to call this. So let's go back to our controller. And here we're just going to new up a queue access class. We're going to bring in that namespace. We're going to access our book club signups queue. And unlike a table, but like the storage account itself, queue names have to be all lowercase or numbers. So you can't do the Pascal, camel, or kebab case in here either. And we're going to add our request just as it comes into us. We don't have to do any special adaptation here. So let's build this, make sure I've not done anything wrong again. Always a good check. Now we're going to push this up to Azure. And while this is building and deploying, we're going to get started on our function in order to read the queue and actually push it into our table again. So we need to add that. Then if I can type, we need to commit it. And then we need to push it again. Do something. Thank you. So I just want to check that the pipeline is kicked off again. Yeah, that's all working. Awesome. Now we can make our Azure function. And for this, I'm doing it inside of a clean Visual Studio because it's not actually connected. And we want to create a new project. And I need to give this a little bit of some special names because if I don't, it all goes wrong. Because all my pipelines obviously depend on certain names. We're creating an Azure function. We're going to call it Book Club Signup Processor. And we're going to be creating that inside of this folder. And that way my repo should pick it up. Now, when you create an Azure function, you get to pick the type of trigger that you want to scaffold with it. And that can be anything from none, you do it all by hand yourself, or you can have blob triggers, Cosmos DB triggers, event grid triggers, HTTP triggers. Fun one here is I didn't need to write that full-blown web API in order to do a really thin API for our app. I could have actually used an Azure function for that too. I didn't, and I'm going to come back to that slightly later on in this talk. What we do want right now is this queue trigger, and I'm going to wire it up to a storage account now so that we can start coding it. So I'm going to wire it directly into my account. I want it to go to my Azure running demo. Then we can enter a connection string name, and again, production code, you are going to put something here. This allows you to set a connection string inside of your Azure function so that in each of your environments, you can point it to the right storage account. Obviously, you don't want to hard code that. For my demo, I'm cheating. If you don't actually give a connection string, it will take the default connection string of your function, and that just happens to be where I've created all of my tables and queues. And then we need to give it a queue name. And for that, obviously has to be the same as we had in our API. So that just needs to be book club signups. So we'll create this. This is a fun part. This sometimes takes like 10 seconds to scaffold, and sometimes it takes 20 seconds. So drum roll, please, and let's keep our fingers crossed that it's not too long today. There we go, that looks good. Now, before I get started, I'm going to do a little bit of cleanup because I don't like this as it gets created out of the box. The first thing that I don't like is the function name being function 1. Why function 1? I want it to be book club signup request. Second thing I'm going to do is rename this function name here, and I'm just going to call it book club signup function. And this is how your function appears inside of Azure. Now, in the past, I made a wonderful mistake. I accidentally did this. I put a space in this function name. It builds. It even builds in the pipeline. It even deploys. However, the function never appears inside of Azure. It never triggers, and I spent an hour pulling out my hair trying to figure out what was wrong. Don't be me. Don't put a space in there. In fact, it's probably a better idea to do something different than just hard coding it to a string. And if we just say name of and add book club signup function, this will now always have the same name as the class that it's sitting inside of. It means that you can't make these mistakes. Then inside of our run, we have a queue trigger. It's going to trigger on the book club signups. And we have this connection string, which we're going to remove because we didn't fill it in the wizard and we're not using it. And if you leave it empty, then it will just look for a non-existent connection string and it will go boom for you. Next up, we have the queue item that we are reading from the queue when we get triggered. And that comes in as a string. Not base64 encoded, that's already been decoded for you, just a JSON string. At this point, we can deserialize it and we can use it. But as with the create if not exists, when checking to see whether or not a queue is built, I don't like writing that code either because it's things that I can get wrong. And we don't need to, because if we tell the Azure function the type of object to expect, it would do that for us. At this point, I'm going to cheat and just copy some code across so you don't have to watch me do some more building. I'm going to take my models from my API and I'm going to take that table access, because we're going to be using that in a second. And I'm going to bring that across to my book club signup processor, paste it in here. And I now have my model available to me, which is awesome. Ignore the fact that the namespace is wrong. I know that you can fix it, and I would fix it, but again, for demo, it's fine. And now if we add this book club signup request to our function, and again, control dot, bring in the namespace, this myQueue item would now be a full-blown book club signup request object that we can just use as a standard object. Awesome, that's just what we want. We also have our signup entity, and we have our storage table access class that we just copied across. The only thing that we need to do to make this work inside of a function is, of course, bring across this NuGet package. Now, I'm not going through building this again with you again because it is literally exactly the same as I just did. You've already seen me do that once. So I'm going to cheat here and just use the code we've already created. We're just going to reinstall the Cosmos table. We're going to say OK to everything. Again, why wouldn't you? And then we're going to make the changes to our function so that we can use this. Now I'm going to copy over the code that we had inside of our API. But unfortunately, that isn't the end of the story to use that code that we've just made. Obviously, control dot because we need to bring in our using statement again. But we still have red squiggles, and that's because we are now inside of an Azure function. Azure functions are generally synchronous static functions. We are using asynchronous non-static code here right now. Well, the first one is really easy. We can make the sign up entity static. It doesn't have anything which is instance related, so that's one problem solved. The second one is that we need to make our function asynchronous, and thankfully they run asynchronously out of the box just with the async tab. So, phew. One last issue. Whoops, that was not what you wanted to press, Stacy. One last issue is we are using request here, and that kind of makes more sense because it is a book club sign up request. So we're just going to rename what we get into our function. Do a build of that before we push it, make sure that it compiles. And then we're going to push this up to GitHub too. And that's all the code that we're going to be making today. So last time playing with the Git command line. At some point, I really ought to make an alias for this just to make it a really simple single command. Add function, and we'll push that one up too. Okay, let's go back to our browser. Check that a different pipeline has run now, book club signup processor. While that's running, let's get some data into our queue. Now, Amy has a husband, Rory Pond. Rory is also with Amy on the TARDIS, but Rory, he's not into 40s crime noir. Anybody who knows Rory, he's into Roman history. So we'll send this in. We will check our table. Let's refresh this page. And we should now have a table which has still only Amy in there. And we have a queue with Rory waiting to join his wife in the book club signups table. So we've now added an extra resource. So while my pipeline is running, let's add that extra resource to our live demo resource group. Let's see whether or not it actually defaults the resource group correctly for us this time. So we're going to add a function app. This one is in the correct resource group. That's good. And we're going to give it a name. And you've guessed it, this has to be unique. And it also runs on that Azure websites.net URL, which means it doesn't have to only be unique for functions. It also has to be unique with the web apps too. Thankfully, we can use camel case here so we can make it readable. So this is our live demo function. And that's available to us. Phew. We're going to be running on .NET again. We're going to be running on 3.1 here because if I click the right button. Come on, cancel. Thank you. We're going to be running on 3.1, not because I don't like running in 5.0, but because functions don't really support it that well out of the box yet. I believe you can do it, but the tooling's not perfect. So for now, 3.1 is just easier. Again, I'm going to be running in West Europe. And then we need to see how to host our function app, because that is different from a web app. First thing that we need is to actually assign it a storage account. Now, I'm going to assign it that one that we just created, that live demo storage account. Something you need to know here, your storage account and your function app need to run in the same region. And they need to do that because your function app, it doesn't actually exist. If it's not running, it's not on the app service. It only lives inside the storage account, and when it gets triggered, it gets copied to the app service, it gets constructed by Azure, and then it's available to you. These things can be a little bit big. You don't want to be copying this data around the world in order to create your function app when you get that cold start request in. So it needs to be in the same region. Now, if you really want to, you can cheat this. You can create it with one storage account, and then you can manually change the setting inside of the function app itself to point to a different storage account that can live in a different region. I have only ever come across one reason when I wanted to do this, and that was at the start of COVID, when it was really limited as what you could create on the type of Azure account that I have. It's possible, but don't do it. Then we need the operating system that we want going to run on. And again, we're going to be running on Windows. Come back to that in a second. And then the type of app service plan that we want, because you do still need an app service plan in order to run this. We have three options. Consumption. This is the cheapest option. You only pay for the invocations of the function that you use. And I believe you get something like 1 million for free per month. It has limitations. You can't protect it inside of your Azure subscription. It's always available to the world. You can't put it in a VNet. And you always have that cold start issue. It can take a while for that first request to run. You can use a premium functions plan. Now here you always have a cold scale out available to you, so that cold start takes much less time. And you can scale out something like 200 instances if you really need mega scaling of your function app. It's also quite expensive. I think it's about 170 euros. Sorry, I work in euros. Out of the box. So this is one that you only really want to use when you need that pure performance. The other option is an app service plan. This allows us to do things like VNet, so our function can be protected from the outside world. And literally, it just runs on a standard app service plan. We're going for the cheapest for the consumption. And that means, like I say, every time we get a new request in, if our function app has timed out and it's been torn down by Azure, first of all, it has to be remade before we can serve that first request. That is why I use a web app on a standard app service plan rather than a HTTP function for my API, because that first request, it can take like 1-2 seconds, and it can also take 20-30 seconds. I've had it once at the slowest, and it's just not something I want to give my users. It is getting better all of the time, and I kind of imagine that at least by the end of this year, if I'm giving this demonstration, I'm going to be running functions the whole way through and being totally serverless. Now, for the Linux versus Windows there, this has a big impact. If you are using a consumption serverless account, then you can't have a Linux consumption-based app service plan in a resource group with any other app service plan. With Windows, you can. So that's why we have a Windows function app service plan here, because I want more than one app service plan in my resource group. You also can't mix Linux app service plans and Windows app service plans. And that's why my web API is also running on Windows. Of course, you can solve this by using 2 resource groups. In production, that's something that you are going to want to seriously consider and have a look at. For a demo, I want to keep it simple and I want to keep it contained, and that's why everything's running Windows. So let's review and create this one. And that is everything that we need inside of Azure to run the application as we have it built right now. Now, let's check my pipeline. That's built. Now, I'm going to do something now which has nothing to do with the demonstration and everything to do with a weird error inside of my pipeline. Every time I restart this demo, I delete my Azure function and I recreate it. And on the first deploy to that Azure function, it doesn't work. The deploy works, but the function never actually seems to get scaffolded inside of Azure. So I'm just going to rerun this stage. And hopefully that should kick off in a second. Hopefully that should kick off in a second. Thank you. And that should deploy the Azure function to us, for us. Let's go back to our Azure running demo. This is always the fun part of this demo, because this is a bit where it's either, hey, look, it's awesome, or you just have to trust me and I have to figure out later why it didn't work. If we have a look inside of our Azure function, the way that we can see what functions are available to us is by looking at this function here. And like I say, we've seen that my pipeline ran, and yet this isn't available. And until this is available, I'm not going to be able to show you the end of the demo. So hopefully this is kind of going to appear sometime soon. because this is kind of the last thing I want to show you. There we go. We have a book club sign up function. So the function's now there. It should have triggered. We go back to our running demo, go back to our storage account and our storage explorer. Drum roll, please. Storage explorer, please. If we have a look in our queue now, it is empty. The function is triggered, it has read that data, and that means that if we look in the tables, Rory has now joined his wife. They're both members of the book club, and we can all celebrate. Let's get back to the presentation to finish off. Okay, the computer's asleep too, it's not just me. So a few things I want to go into about some of the things we were looking at when we performed this experiment and started playing with these things. The first one was the cost. Like I say, our budgeting department, they really didn't want to go to Azure. They were terrified that we were going to move out of our custom data center and we were going to spend hundreds of thousands of euros a month in running our website. Well, let's start with something smaller than an entire website. This talk, lots of practice, lots of dry runs, lots of mistakes, and giving this talk several times over the last year, I have spent out of my own pocket a total of about 20 euro cents. And I did that just by making sure that I used the minimum resources possible. Now, of course, for such a tiny demo, you would expect it to be cheap. I am still really impressed at the 20 cents because to host this on a dedicated plan by even a cheap hosting provider is still going to cost you way more than 20 cents per year, but it's still something that you expect to be cheap. Let's go bigger. Our hack week. We had a department, 35 developers, 6 different teams using all sorts of different options inside of Azure. Not just functions and storage accounts and app services, but machine learning, Signal R services, all sorts of things. And not only did we have that hack week, we also had a week before the hack week where our ops team was busy playing, trying to make sure that they knew what we were going to be doing and it was going to be secure enough for them. And a colleague and I working on an Azure workshop so that our developers that had never used Azure before could hit the ground running before we started our hack week. Our total cost for both weeks was 25 euros. And we kind of did that by making good use of the Azure cost calculator. We made sure that we figured out the lowest things that we needed to use. Things that we thought would be cool, but we didn't necessarily need, we managed to not make because we checked the price of them and it wasn't worth it for us. It wasn't going to give us value, so we ignored it at that time. It's important to do this because you do need to be very careful when using cloud services. If you do something wrong, you can get very big bills indeed. And I do know somebody that provisioned something that they thought they would need, and I can't remember what cloud provider it was in, but they suddenly got a bill for 10,000 because it wasn't a consumption-based thing. It was 10,000 per month for what they provisioned. They weren't the most popular person, and they learned their lesson from doing this. Learn from their lesson, be careful. So play, experiment, try things out. This is such a cool thing to play with and to learn. And if you are lucky enough to have a Visual Studio subscription on a yearly basis, then you can do this really easily. You have Azure credit available to you. Somewhere between 45 and 130 euros per month. I'm not sure the dollar figures. I think it's about $150 or so maximum. And you get that each month of your subscription. Use it if you have it. Because even if you do something wrong here, and I've done this, you don't end up charging yourself a fortune. That credit that you get is also a credit limit. If you hit that, you don't pay anything extra. It just means that your resources are unavailable until your next billing period. Certainly not useful, but better than a huge bill. If you don't have the luxury of that Visual Studio subscription, then obviously you can always take your own subscription. If you do this, then you get 12 months of selected services for free. You get 170 euros of credit for your first month, which I believe acts the same as the credit in a Visual Studio subscription. Once you hit it, you just can't access your resources until you remove your spending limit. After the first month, it gets a lot more dangerous. Then it's your credit card that's going to be hit. Excuse me. So if you do go this route, be careful and make sure that you do use that price calculator. Otherwise, it's going to hurt. It's perfectly doable if you are careful. This whole demonstration, it isn't actually in my Visual Studio subscription. I run this in my personal subscription. And again, by making sure I know what I'm using, I keep the costs really down to earth, and it is amazing how much value you can add without spending that much money when doing this. So, like I say, now you've seen hopefully how easy this is. I invite you, go play, make a simple framework, see what you can do. Like I said, this was a bit of a fast run through, but there's a QR code on the screen right now that will take you to a blog post that will run you through both the application and the resource that I've just created and used, and show you how to deploy it from inside of Visual Studio. And there's lots of links in those blog posts to MS Learn and MS Docs. Thank you for your attention this evening. I hope you've enjoyed today's session. Thank you for your time.
And thank you for your time, Stacy, especially since it's after midnight there, and I know it's a bit of a struggle, but you did an excellent job and got through it A-okay.
Thank you so much. It was, my voice is going at the end of the day. I've been up now for, what time is it? I've been up for about 17 hours now, I think. So it's my voice is starting to go, but that was so much fun to do.
Honestly, you didn't skip a beat. I mean, you did perfect. You were on the money.
Thank you very much.
So thanks again. If anyone has any questions for Stacy, again, feel free to either enter them into chat or speak up verbally. There's a couple comments in chat thanking you and telling you that it's a great talk. And
yeah, thank you so much, everybody.
Likewise, I will post a couple links before people leave. So there's links to the YouTube channel, as well as my blog, which has the tech events. And more importantly, there's a link for the tech evaluation for Stacy's presentation. It's the least we could do to thank her is by filling out the eval and providing some valuable feedback. I also wanted to take a minute to go through some of the events. So let me go ahead and share my screen. So within the chat, I posted 3 links: YouTube, the blog, as well as for the feedback eval. So if you would please take a minute to fill those out. Also, I'd like to cover virtual events that are going to be happening. On May 4th is the Ohio North Database Training Group, and that's going to be meeting online. They have a very interesting topic. It's going to be about communication, interpersonal communication, and email communication with colleagues, especially in the technical realm. How to communicate without sounding, without coming across as arrogant or offensive. So it should be a very interesting topic about soft skills. On Wednesday, May 19th, is the Hudson Software Craftsmanship Group, and the meeting information is posted on meetup.com with that link. And all these links are already posted on my blog with the link that you have available to you in chat, so you can jump to them and be able to access them. On May 20th is the Great Lakes Users Group.net. They don't have a topic posted yet. However, they always maintain monthly meetings, so there will be a topic that will be posted there. And once you subscribe to that group, you should be able to get notifications of updates. And then on May 27th is the May meeting of our group. We're going to be meeting same time, same place. And we're going to have Jason Bach talking about code generators in our May meeting. As far as virtual conferences, this weekend, April 24th, is the Global AI Student Conference. And you can sign up for that and learn a great deal about AI and a variety of AI topics. and that is free of charge, and it will be happening this Saturday. On May 4th is MDC, or the Minnesota Developers Conference, and the link for that is mndevconf.com. And then on May 7th is Stir Trek. That is a Friday, and Stir Trek this year will be virtual, and I believe they have unlimited tickets available if you're attending online, and the link for that is stirtrek.com. Last but not least, May 10th, SQL Day Poland. So although it's in Poland and although it's about SQL, technically all developers work with data. So this should be a valuable conference to be able to learn more about SQL Server and how it can be adapted within your development environment. So the link for that is sqlday.pl, and if you prefer to read it in English like I do, you want to add in a /en at the end. So once again, those links are already posted on my blog, and you have the link in chat. Also, another thing I always like to cover are job openings. So Tech Systems being one of our sponsors, they always have jobs available, and you can check them out over at techsystems.com/itjobs. And I also like to ask, who's hiring? Feel free to enter into chat or speak up verbally. If your place of employment is hiring, please speak up. Go ahead.
Hi, Sam. I'm actually from Tech Systems. This was a great learning opportunity for me, so thank you so much. And Stacy, thanks for doing this so late in your time.
You're welcome.
I do want to say that I learned a lot and am excited to share this with my coworkers. But feel free to connect with me on LinkedIn if I haven't already connected with you guys on LinkedIn. But I'm willing to share opportunities we have in the .NET space. We have a ton of opportunities right now, remote, but also on site. Some downtown, some in the Akron area, and some in Westlake. So feel free to connect with me, and I look forward to hearing from you guys. Thank you so much.
That's good to know. If you don't mind, could you post either your email or your LinkedIn address in the chat so others can get in touch with you?
Yeah, would love to. Thanks, Sam.
Excellent. Thank you, Jillian. The other question I always like to ask is, who's looking for work? So if you don't feel like speaking up verbally or making it known, you can email me, and I would be happy to connect you with either Jillian or anyone else who may be looking for work. Last but not least, my contact information, if there are any questions I can answer for you, either regarding this meeting or future meetings, you can reach me, snasser@nistechnologies.com, and you can also find me on Twitter, and there's the link to my blog, and I also invite you to connect with me on LinkedIn. And so with that, if there are no questions, once again, I strongly ask or strongly urge you to fill out the eval form so we can provide some feedback for Stacy. Other than that, if there's no questions or comments, we can call it a meeting, and thank you all for attending, and thanks again, Stacy.
Yeah, thank you for having me. Have a good evening, all.
I do have a question.
Yes, please, go ahead.
You still here, Stacy?
Yeah, I'm still here.
Okay. Yeah, so I'm just curious, like, you started out the presentation with code, and then you got into provisioning and all that. Is that, and I think you mentioned that there was something about that Azure would calculate certain things based on the code you already had in place. Is that correct? Did I hear you correctly?
It's not that Azure will calculate things based on your request, but it's when I think you mean when you're creating tables and when you're creating queues. Azure, as long as you use that create if not exist async, then as long as you have a storage account, Azure will create the tables and the queues on the fly for you.
So is it normal in your practice to like write code and then start and then set up a space in Azure for the project? Like the way you did this?
If I'm running a production build, what we do in the office, the first thing that we do when we create a new project is make sure that we have a deploy pipeline available and all of the infrastructure as code is available. But what we don't do is put our table names inside of our infrastructure as code. So the infrastructure as code makes sure that we have the app gateway, the VNets, the storage accounts, the app service plans, etc. And then the code itself makes sure that it has the tables within those storage accounts.
Another question I had was, and I'm not a .NET coder, so or an Azure user or anything, but you created a function app. What exactly is that?
An Azure Function app is a serverless way to execute code inside of Azure. So you can have various triggers inside of a function app, like say you can have HTTP triggers to use it as an API, or the one that we use today, which is a queue trigger. And basically your app just doesn't exist if it's not being used. So on the first request, Azure will retrieve your app from the storage account. It's why you need to be in the same region of your function app and your storage. It will put that all together for you. It will run your function app, and you pay for the invocations that you have on top of that if you're running in the consumption layer. After the app has been running for an amount of time, if there's no more requests coming in, Azure will tear it down for you, and it doesn't really exist again until the next request comes in. The advantage there, of course, is on the consumption list, you just pay literally for what you use. I say you get 1 million invocations free per month, I believe. And it's a very cheap way of running a small API on the back end. If you're using your own app service, then it means that if you've got different functions that you know are going to be firing at different times, that you can use your app service with a lot more, my head's empty, what's the word I'm looking for? Sorry, my English is gone at this time of the morning. Efficiency. You can run your app service with a lot more efficiency because you don't need your app service to run this one API, which is maybe only going to be called X amount of times during the day. You can actually have an app running various different functions apps, which can be in there when they need to. So it just makes life a bit more efficient for you, saves you money. There are downsides to using it. It is more complex, for example. So it's one of those things that examine it if you're going to use it. And if it makes sense for you, it is awesome. If it doesn't make sense for you, that doesn't make what you're doing a bad thing.
And could you explain the term serverless?
Serverless simply means that you're running on somebody else's server, basically. It means that I don't know what computer that function is running on, and more to the point, I don't care what function that what computer that function is running on.
Well, isn't that the whole point of cloud computing?
It is the whole point of cloud computing, but if you have things like an app service, then you provision hardware. So when I provision an app service for the web app, I am saying I want something available to me, and that is basically my hardware. When I do a consumption-based function, I'm not doing that. I'm just saying, just give me this function. How you run it is entirely your thing. Just give me this function. And it's the same with the Azure storage account. That's also serverless. I don't say what disks I want. I don't say what machine I want for accessing that data. I just say, give me an app service and you deal with the rest of it. I just want a REST interface that I can access.
All right. That helps. Thank you.
You're welcome.
All right. Doesn't look like we have any other questions. So thanks again, Stacy. We'll let you get some rest before work in the morning.
Yes, thank you. It's I've got an alarm in 3.5 hours, so I think it's time for me to hit the pillow.
All right.
Have a
Take care
pleasant
and
day.
have a good night.
Yeah, bye.